Hello, we are Lorena and Dyadha, and we are going to talk about hypothesis testing for means. First, it is important to understand a couple of terms or concepts so we can be in tune. So let's talk about parameters and a statistic for hypothesis testing. A statistical hypothesis is a statement about the values of a population parameters, and it can be proved using the information contained in a sample. To test the statistical hypothesis are used different estimates depending on what we want to test and the available data. An estimate is a statistic which estimates the specific value of a parameter and can be of two types, point or interval. For this test, we are going to work with means, which are point estimates of normal distribution. To propose the hypothesis to be tested are used the terms H0 or null hypothesis and H1 or alternative hypothesis, which sets the guidelines of the comparison to be made. This can be comparing two different means in the case that we want to see the relationship between two different samples, or comparing a mean with a specific value, which can be 0 in the case that we have only one sample. These are the variants of hypotheses that can be proposed. For the comparison of means, that can be two-tailed test or one-tailed test, or the comparison of one mean to a specific value, considering that in this case, mean 0 equals to a specific value, and it can also be two-tailed test or one-tailed test. Also, it is important that you understand the difference of a two-tailed test and a one-tailed test. Although the two-tailed test has a bigger rejection area than one-tailed test, the last is more specific test, normally used when you have an idea of where can be located the value of the means. This can be visualized graphically here, knowing that 1 minus alpha refers to the acceptance area. To test this hypothesis, we are going to use a test statistic, which is a number whose magnitudes allow to know whether H0 is either rejected or failed to be rejected. For this, we must take into consideration the statistical significance, which represents the risk you are willing to take while you are carrying out the test. This value of significance is used both when performing the calculations and when searching for the test statistics, and conventionally is 5% or 1%. To know if it is rejected or not, we guide by the acceptance or rejection areas, which are the range of value of the test statistic where H0 will be failed to be rejected, and the range of values of the test statistic where H0 will be rejected respectively. Here you will notice later on when we explain the different cases that the conditions where H0 is rejected or no can vary. There are two types of error. Type 1, alpha equals to p, occur when H0 is true but we rejected it. Type 2, beta equals to p, occur when H0 is false but we failed to reject it. To support the point estimates, it is important to obtain short intervals with high confidence levels. The confidence intervals are calculated with different formulas depending on the case.
In any variant that you could use, when conducting a hypothesis test, you have to follow the next general steps. Take a random sample to get the data that you will use to perform the analysis. Compute the test statistic using the corresponding formulas for each variant. Find a critical value using the statistics tables, compare these values, and finally, reject or fail to reject the null hypothesis. Now you know the basic concepts and steps to perform successfully a hypothesis test. Let's start to practice analyzing an example for the first type of test. In this table, you can see the tension bond strain data from a cement formulation experiment. We have a sample size of 10 for each formulation. The experimental results are shown in this table. The two-sample t-test is used when it is assumed identical population variance for both samples. In order to calculate the t-statistic, you have to calculate the size, variance, and mean of each sample. For this step, you can use a calculator, Excel, or do it by hand. Since in this case we have an unknown variance, we have to obtain an estimate of the common variance. Now, we can calculate the test statistic using the t-distribution table. In this case, we have to calculate the degrees of freedom considering the size of the sample minus 2. And also, we need to find the critical value considering the significance or alpha level. That usually is 0.05, which means a confidence level of 95%. Here, it's important to say that when making a two-side test, we have to find the critical value with a significance of alpha divided by 2. Finally, we compare both values under the following conditions. If we conduct a two-side test to prove that the means are different, the absolute value of the calculated statistic must be greater than the critical value to reject the null hypothesis. But if we are conducting a hypothesis test for only one tail, the formulas and the conditions to reject the null hypothesis are a little bit different. But it doesn't matter if we are proving if one mean is greater or smaller than the other one. We always use the same amount of freedom degrees that in the two-side test. In this case, the absolute value of the test statistic is 2.2. Since it is greater than 2.1, that is the critical value, we reject the null hypothesis that the means are equal. In the second test, we fail to reject the null hypothesis, and in the last test, we reject the null hypothesis that says that the mean 1 is equal or greater than the mean 2. We can use confidence interval, which the value of the parameters is expected to lie. In this case, we can get an interval for the means difference using the following formula. The interval must match with the conclusion obtained from the hypothesis test. In this case, since the mean for each sample is supposed to be different, the zero shouldn't be present in the interval because it means that the means are different and this doesn't match with our previous conclusion. Another variant of the two-sample test appears when the population variants are unknown and different. In this case, we calculate the test statistic using the following formula, where each sample variance is considered and also the way to obtain the degrees of freedom is different, because we don't use n-2. Instead, we have to calculate them using the following formula and then round to the nearest value. In the previous test, we considered unknown variance, but if the variances are known or if both populations follow a normal behavior or the samples are larger than 30, we use a c-statistic instead of the t-distribution. We obtain the test statistic using the following formula. In this case, there are not freedom degrees. Instead, we look at the c-distribution table for the confidence we determine. For example, if it is specified an alpha value of 0.05 and we are conducting a two-side test, we look for 1 minus alpha divided by 2, that is 0.975. And if it is a one-tail analysis, we look for 0.95. As you can see, the way to reject the null hypothesis is similar to the previous cases, and also we can find a confidence interval following this formula. The last variant to perform a hypothesis test for mean is comparing a single mean value with an specified value. In this case, that the population variance is known, we use a c-statistic. If the population is normal or if the sample size is large enough following these formulas. But if the variance is unknown, we have to use the t-statistic distribution. Real applications of hypothesis testing include social science experiments, biology analysis, industrial processes, and quality management.
As you can see, hypothesis testing is one of the most important and formal techniques used by statisticians to accept or reject a statistical hypothesis. Although it is a very simple method, it's very important to consider when to use each variant so the result can be the more accurately possible.